It is the 15th of June, 1940, and the rain falls steadily on the Thames estuary. A lorry rattles across the countryside towards the water's edge, and the men aboard it know they are building something that may well save their nation. They are not engineers in the conventional sense. Many are local volunteers, soldiers hastily reassigned, workers pulled from factories and farms. The cargo in the back of their vehicle is deceptively simple: welded steel, concrete, iron bars, and chains. Within hours, these materials will be transformed into something far more sinister. Beneath the murky water of Britain's rivers, an ingenious trap is being constructed. It is a device born of desperation, designed to turn the very geography of the British Isles into an instrument of war. This is the story of how Britain weaponized its waterways, how engineers and soldiers conspired to make invasion not merely difficult, but catastrophically expensive in blood and machinery. By the autumn of that year, dozens of British rivers would bristle with these obstacles, creating zones of water so treacherous that no conventional landing craft could traverse them without suffering crippling damage. Yet today, few people know these defenses existed. The concrete has eroded, the metal has rusted away, and the urgency that drove their construction has faded into historical obscurity. What remains is a testament to the ingenuity of a nation fighting for its survival, and a reminder that sometimes the most effective weapons are the ones nobody remembers were ever there. The summer of 1940 was unlike any other in British history. France had fallen with shocking speed. The Wehrmacht had demonstrated a form of warfare that seemed to render traditional defenses obsolete. Tank formations could sweep around fixed positions, paratroopers could land behind lines, and amphibious assault had proven devastatingly effective in Scandinavia. The British government faced an appalling reality. Invasion was not merely possible, it was, in the assessment of many military planners, inevitable. Germany possessed naval assets, transport aircraft, and landing craft in quantities that Britain simply could not match in open water. The Royal Navy remained superior, but only just, and a concentrated German assault could potentially punch through. What Britain could not do was fight the Wehrmacht in the open countryside. The army had been catastrophically weakened by the evacuation at Dunkirk. Equipment losses were staggering. Tanks numbered in the hundreds, artillery pieces scattered across French beaches or sunk in the Channel, vehicles of every description left behind in hasty retreat. The British Expeditionary Force had escaped with its soldiers, but little else. Reinforcements were on order from America, but America was still neutral, and supplies were trickling in at a rate that could not possibly match demand. The invasion, when it came, would likely succeed on the beaches. Germany would establish a bridgehead, land follow-up forces, and the thin green line of the reconstructed British Army would be overwhelmed. The only way to prevent this catastrophe was to make invasion so costly that Germany would abandon the attempt. This meant making every single approach to British shores as hostile, as lethal, as geometrically impossible as human ingenuity could devise. The beaches themselves could be obstructed, but beaches are vast. What about the rivers? Britain is laced with waterways: the Thames, the Medway, the Humber, the Tyne, the Severn, the Mersey. These water barriers offered something precious: choke points. A German force attempting to push inland would have to cross them. If those crossings could be rendered impassable, if every bridge could be destroyed and every ford could be transformed into a killing zone, then the inland advance could be fractured, slowed, and eventually halted. The technical challenge was formidable. The obstacles needed to be effective against landing craft, amphibious vehicles, and conventional boats. They needed to be difficult to detect and even more difficult to remove under fire. They needed to survive in salt water and fresh water to withstand tide and current and the weight of military equipment. And they needed to be manufactured and installed in quantities sufficient to cover hundreds of miles of waterway in a matter of weeks. The solution came from the design teams working frantically at military engineering establishments across the country, but particularly from those based at the War Office engineering establishment in Surrey, and the Ministry of Supply's experimental facilities. The thinking was radically practical. If you cannot stop an invasion by force, you stop it by making the physical act of crossing water impossible without suffering unacceptable damage. The device that emerged from these drawing boards was known officially as the anti-landing obstacle, but soldiers referred to it simply as a dragon's tooth, or, more commonly, a Belgian gate. The latter name originated from similar devices that had been hastily constructed in Belgium during the spring of 1940, though the British version was considerably more sophisticated and purpose-built. The basic design was a framework of rolled steel, typically 8 feet, approximately 2.4 meters, in width and roughly 4 to 5 feet, 1.2 to 1.5 meters, in height. The frame was constructed from angle iron, welded together with considerable skill. This was precision work, as any weakness in the joints could lead to the entire structure buckling under the impact of a landing craft. Across this frame, bars of steel were welded at intervals, creating a barrier that was strong enough to rip open the hull of a wooden or lightly armored vessel. The weight of a completed frame was approximately 1,500 to 2,000 pounds, 680 to 900 kilograms, a mass that required considerable effort to maneuver into position. Manufacturing these obstacles became an enormous undertaking. Factories across the Midlands and the North were converted to production. Steelworks in Sheffield, Birmingham, and Coventry began running extra shifts, feeding steel strip into cutting machines, shearing it to precise lengths, and passing it along to welders who worked with extraordinary speed and accuracy. A single factory might produce dozens of frames per week. By the end of 1940, British industry had manufactured tens of thousands of these obstacles. The installation process was equally remarkable. Royal Engineers units worked in coordination with local volunteers and labor corps. In rivers, the obstacles were sunk and anchored to the riverbed using concrete blocks, chains, and steel cables. The concrete blocks themselves were manufactured in enormous quantities, vast pyramidal forms, some weighing several tons, which would serve as immovable anchoring points. The obstacles were positioned in staggered rows, creating a barrier that could not be cleared by simply removing one or two. Any attempt to navigate through them with a landing craft would require the vessel to slow to near walking pace, making it an easy target for machine gun fire from the banks. In coastal areas and estuaries, the obstacles were positioned at different depths to account for tidal variations. In shallow water, they might rest on the riverbed entirely. In deeper sections, they were suspended from floating markers and cables, positioned so that they would strike any vessel attempting to pass. The density of these installations was carefully calculated. A river might have 10 or 15 rows of obstacles stretched across its width, with each row containing dozens of individual frames. Some rivers were so densely obstructed that the water between them became almost completely blocked. Installation crews worked in constant fear of German air attack, though such attacks were sporadic once the Battle of Britain shifted the aerial advantage towards the British. The work was exhausting and dangerous. Men worked in cold water, handled heavy steel in muddy conditions, and operated in areas that remained vulnerable to enemy action until the moment of invasion had definitively passed. The deployment of these obstacles followed a logical geography. The Thames, being the most likely invasion route and the closest approach to London, became the most heavily fortified. Every significant tributary was obstructed, every fordable crossing rendered impassable. The Medway, which flows through Kent, the invasion coast, received comparable treatment. The Humber, offering access to the industrial heart of Yorkshire, was similarly transformed. The Tyne, protecting Newcastle and its vital shipyards, bristled with obstacles. Along the south coast, every river and stream that might offer an anchorage or landing zone was fortified. The Severn, the Mersey, the Ribble, all were converted into defensive barriers. The psychological impact of these installations was considerable. To a German planner considering an invasion of Britain, The presence of these obstacles represented an escalation in defensive capability that was difficult to counter. Landing craft could be armored against machine gun fire, but they could not be armored against being ripped open by steel barriers. Removing the obstacles under fire would be extraordinarily difficult. Attempts to do so would expose engineering teams to devastating fire from defending troops. The obstacles made the prospect of establishing and consolidating a bridgehead exponentially more challenging. Some German documents from the planning phase of Operation Sea Lion acknowledge the obstacle program with considerable concern. The obstacles are described variously as extensive, formidable, and a serious complication for amphibious assault. What records remain from the German side suggest that the obstacles were more effective as a psychological deterrent than they might have been as a physical one. A determined German force with adequate engineering support might have managed to clear some of them, though at considerable cost and time. But the obstacles, combined with other defensive measures, British naval superiority and air superiority by late 1940, made the invasion seem increasingly unfeasible. The obstacles served their purpose not by sinking vast numbers of German vessels, they never were tested against actual invasion forces, but by contributing to the overall defensive picture that made invasion seem impractical. The British obstacles differed markedly from German and American attempts at similar systems. The Germans, anticipating the need to defend their own coasts as the war turned against them, developed obstacles of their own. The hedgehog designs they employed used tetrahedra of steel, angular structures that were difficult to remove and caused considerable damage to landing craft. However, the German obstacles were less systematically deployed and manufactured in far smaller quantities. The American obstacles, developed in response to the German designs and refined through hard experience in the Pacific, eventually became standardized across all Allied forces. The American horned obstacles, the tetrahedra, and other designs shared common principles with the British innovation, though American manufacturing and deployment methods differed considerably. What distinguished the British approach was its integration with the broader defensive strategy. The British obstacles were not merely anti-landing devices. They were part of a comprehensive riverine defense scheme that included pillboxes, anti-tank guns, anti-aircraft positions, and prepared defensive lines. A German force attempting to cross a British river would not merely face obstacles in the water, it would face interlocking fields of fire from the banks. The obstacles served to funnel the enemy into predetermined kill zones where defending troops possessed overwhelming advantage. This integration made the British system significantly more effective in theory, though it was never tested under actual combat conditions. The sophistication of the British approach impressed both American and Soviet observers. When American military delegations visited Britain in 1941 and 1942, they studied the obstacle systems extensively. The principles demonstrated in British river defenses influenced the development of American amphibious assault doctrine. The Soviets, facing the prospect of defending their own rivers against German assault, noted the British innovations with interest, though their own defensive approaches were necessarily different due to the scale of the theater and the resources available. The actual impact of the obstacles on the course of the war was, in one sense, entirely notional. They never faced the test for which they were designed. Operation Sea Lion was postponed, then indefinitely abandoned. By the spring of 1941, Germany had turned its attention to the Soviet Union. The threat of invasion receded from the realm of probability into that of theoretical possibility. Yet the obstacles remained, a physical testament to a moment of national crisis and collective ingenuity. Their impact was felt nonetheless in subtle ways. The very existence of the obstacle program demonstrated to the civilian population that the government was taking the threat of invasion seriously, that plans existed to counter it, that the nation would defend itself whatever the cost. This psychological impact was significant. The presence of obstacles in local rivers, visible to anyone who lived near them, reinforced the sense that invasion was being prepared for, that beaches and waterways would not be surrendered easily. For the military, the obstacles represented a demonstration of what could be achieved when resources were mobilized for a specific defensive purpose. The success of the program influenced subsequent thinking about amphibious assault. Later in the war, when British and American forces were contemplating amphibious operations in occupied Europe, the lessons of obstacle design and removal became increasingly relevant. The engineering innovations developed to clear obstacles in preparation for D-Day owed much to the experience gained from working with the British river obstacles. The obstacles also represented a form of technological innovation that was distinctly British in character. The design philosophy, practical, adaptable, easily manufactured, reflected the pragmatism of British military engineering. There was no attempt at excessive sophistication. The obstacles worked because they were simple and robust. They were manufactured by conventional means using standard materials. They could be maintained by soldiers with minimal training. These characteristics made them replicable, teachable, and ultimately transferable to other theaters and other contexts. If you are finding this fascinating, a quick subscribe helps more than you know. The algorithm does strange things, but support from viewers genuinely allows more documentaries of this depth to be produced. Now, back to the rivers of Britain and their hidden history. By the autumn of 1941, the obstacle program had effectively concluded. The immediate threat of invasion had passed. Germany was committed to the invasion of the Soviet Union, which consumed the vast majority of German military resources. Britain shifted to a strategic posture based on eventual counter-invasion rather than defense against invasion. The obstacles remained in place, however, and for several years they were maintained as part of the coastal defenses. As the war progressed and Allied air superiority increased, the resources devoted to maintaining the obstacles gradually declined. Some were removed to allow river traffic to resume. Others were simply abandoned as the war situation stabilized. By 1943 and 1944, most of the obstacles had been taken out of service or allowed to deteriorate. The concrete anchoring blocks remained longest, visible in riverbeds well into the post-war period. Some, indeed, remained visible into the 1950s and 1960s. A few examples were preserved as historical monuments, though most were eventually removed entirely. The historical legacy of the obstacles is curiously muted. Unlike coastal fortifications such as pillboxes, which remain visible in many locations, the obstacles were aquatic installations, and they left little permanent mark on the landscape once they were removed. Surviving examples are rare. A few restored specimens can be found in military museums. Notably, the Imperial War Museum in London possesses several examples of different obstacle designs. Walking along the Thames or the Medway today, it is almost impossible to visualize what these rivers looked like in 1940 and 1941, when they bristled with steel barriers stretching from bank to bank. Yet the rivers remain, and in their currents flows the memory of that moment when Britain mobilized its industrial capacity and military ingenuity to turn geography itself into an instrument of national defense. The story of the river obstacles is ultimately a story about what nations do when faced with existential threat. It is about the mobilization of resources on an unprecedented scale, the conversion of civilian industry to military purposes, and the subordination of ordinary life to the requirements of survival. It is about engineers working from first principles to solve novel problems. It is about soldiers and civilian workers laboring in difficult conditions to implement solutions they understood to be essential. The obstacles never face the test for which they were designed. In one sense, this might be considered a failure, defensive measures that were never needed. But in another, more accurate sense, it was a complete success. The obstacles were part of a comprehensive defensive strategy that made invasion seem increasingly unfeasible. When Germany canceled Operation Sea Lion, It did so partly because the expected air superiority had not materialized, partly because the invasion fleet was inadequate, and partly because the prospect of forcing a crossing against a prepared and determined defense seemed impossibly costly. The obstacles contributed to that calculation. They were one component among many: pillboxes, anti-tank guns, trained soldiers, naval superiority, but they were a visible, tangible component. They represented the physical embodiment of the British determination to resist at any cost. To walk a British river today and attempt to visualize what lay beneath its surface in 1940 and 1941 is to touch something profound about how nations respond to crisis. The obstacles have been forgotten, their steel rusted away or removed, their concrete anchors buried in river mud. But for one extraordinary moment in history, they transformed ordinary waterways into instruments of war, and in doing so, they played a small but real role in determining the outcome of one of history's most consequential conflicts. The rivers of Britain were weaponized not against an invader who came, but against the mere possibility of invasion. That mobilization of defensive capability, that commitment of resources and effort to a threat that never materialized, represented something uniquely British in character, the paradox of defense so thorough that its very effectiveness meant it was never tested. The obstacles remain, in memory, if not in substance, a monument to resilience, ingenuity, and the determination of a nation to defend itself with whatever means lay at hand.